Hey guys, this is the video for lesson 10.2, and before we started, I just wanted to go over some notation, some symbol notation for circles that I think will make life easier for us as we go through here. So we're going to be looking at some problems that typically have three different types of notation. First of all, we have angle notation. Okay, I'm using crayons because that's what I've got. So when we talk about angle notation, this is what we've been using all year long. So I can talk about angle A, B, C, and if I'm talking about angle ABC, I mean this angle here. All right, it's actually an angle. Okay, A, B, C, the angle part of it inside there. Okay, then I have arc measurements. Okay, so if I see this AC with a little arc over it like that, that means I'm talking about this portion of the circle that's directly from point A on the circle to point C on the circle. Okay, so that red part there is arc AC. Okay, now this means something a little different. If I have a DC, that means the arc that starts at A goes through D and around to C. So that would be the entire thing like this, all the way around. So I hope you can see the difference between arc AC and arc ADC. So arc AC is the little one directly between A and C. ADC connects A and C, but it goes through D, so that means all the way back around on the other side. Okay, I think that'll be helpful going forward in lesson 10.2. Okay, so let's start with just some notes up at the top. Okay, so here we're going to be studying the central angle of a circle. Okay, the central angle of a circle. A central angle is an angle with its vertex at the center. Okay, here the vertex is B, so the vertex is at the center of the circle, and its two sides are radii, the plural of the word radius. So each side of that angle is a radius. So we have segment BA is one side, and segment BC is the other side of that angle, and they're both radii of the circle. Okay, so and then you can just to fill this in, angle ABC is a central angle in the circle B to the left. We call it circle B because the center is B. Okay, the sum of all central angles in a circle is 360 degrees. You probably already knew that. That all the angles in a circle, that a circle total is 360. So if you chop that up into little pieces, then clearly they're all going to add up to 360. Okay, so let's see. The measurement of the arc formed by the endpoints of a central angle is equal to the degree of the angle, or to the measurement of the central angle. Okay, so here in this case, 84 is the measurement of the central angle, so that's also the measurement of arc AC. Okay, and the measure of ADC, the big angle here, is going to be just the difference of 360 and 84, so 276. Okay, has to be a sum of 360. All right, so let's just go through a few of these together. Number one, we're looking for ST, okay, arc ST, and we said it's the same as that angle measure, so it's just going to be 122 degrees. Okay. Now, RT is a diameter, okay, it's a diameter. It goes through the center, and it has endpoints on the circle. So that means this is a straight segment or a straight angle, so it's 180. Diameters are always 180 degrees. This portion of it is 122 degrees, so that means this part would be 58 degrees. Therefore, the arc associated with that central angle would also be 58 degrees. Okay. The next part says SRT. So R has to be between. So from S through R around a T. Well, we already said that this portion is 180, and we just said that this portion is 58. So if we just combine those, we get that this one is 238 degrees. Okay. Let's look at number 2. So with number 2, the first thing I see here is that this angle is vertical to that one, so they're going to be the same. So I'm going to go ahead and write 21 degrees in there. Okay. Now these two are also vertical, so that means they have to be the same. And I know I'm jumping ahead, maybe I haven't started over here yet, but if we do some quick math, if we start with 360 and subtract 21 and 21, so 360 minus 42, I get 318, and then divide by 2, I got that each one of these has to be 159, and that's because they're vertical angles. Okay, so now that I have that settled, I'll go through here and answer the questions. JK, arc JK has to be 21 because that angle is 21. Angle JNM, we decided, has to be 159. Arc KL, then let's see here, would also be 159 because this angle is 159. Arc JKM, okay, JKM, not L, but all the way to M. So we would add these three together, and 21 and 21 and 159 added together is 201. And then MKL, so from here all the way around back to L, it's essentially the only thing we're not including is this 21 degree sector. So 360 minus 21 is 339 degrees. Okay, so you can pretty much do all of these like this. It's you're going to use vertical angles a good bit. That's going to help out a lot. You need to remember that you have anytime you have a diameter, that gives you 180 degrees total. It's very important to remember that. Let's go ahead and do number 3 while we're doing it. So here we notice that they give me an actual arc measurement. Well, the central angle is equal to that. So in here we have 72 degrees. Okay. Let's see, is that one of our WX? No, I don't see it, but that is necessary to be able to finish the problem. So like I said, WU is the diameter, measures 180. So if I start with 180 and subtract 87 and subtract 72, I end up with 21. So this little slice in here is 21 degrees. I know it's hard to see that. Okay, let's see what else have we got. We have a vertical angle over here, 72 degrees. So then this has to be 360 minus all that, right? So 360 minus 72 minus 72 minus 21 minus 87 would leave me with 108. So this one down here, this angle and the corresponding arc both measure 108. Okay, so now we should be able to answer these questions. So we have UXV. Okay, well, we already said that that's 72 degrees, the angle. Arc ST is equal to 21 because that angle was 21. WV, arc WV, we said is 108. TW is 21 plus 72, so 93 degrees. And then TVW, so start at T, go through V, and around to W, so we would need to add 87, 72, and 108, which comes to 267 degrees. pretty simple. I will leave number 4 for you to work on. And let's move on to the back. You can also work on number 5. Let's look at number 6 together. Let's look at number 6 together. Alright, so I have vertical angles. Let's shuffle some papers around. I have vertical angles here and here, so 2 pairs of vertical angles here and here, which tells me that this would be, let's see, yeah, 26, 26. 15x minus 26 is both of these. Those are also those angle measurements. I'm supposed to be finding, let's see, what am I finding? Find each value or measure. Okay, I'm looking for x. All right, so there's a couple different ways you could set this up. Because these two are on half of the circle, and I know that because this is a diameter, right? So remember, these two angles together have to be 180. So that means these two arcs together have to be 180. So I could set it up like that, where I say 15x minus 26 plus 26 equals 180. Okay, these two cancel out. So 15x equals 180. Divide both sides by 15. And x is 12. So that's one way to do it. You could have also just subtracted 26 from 180 to get this angle, which would be 154. So 15x equals 15x minus 26 equals 154. Solve that. You end up with the same thing. X is 12. Okay. So there's that one. Let's see. Let's do number 7. We can do number 7. So once again, we're finding x. I can see that. Okay, these two. I'm just looking at vertical angles here. Okay, so I have these and these crossing. Okay, so I'm going to combine these two, and I'm saying that those, when you add those together, it's vertical with this one. So 103 equals 18x minus 2 plus 15. Okay. So 103 equals 18x plus 13. So 18x equals 90. X is 5 when you divide both sides by 18. So now there's multiple ways to do all of these. This is just kind of the first thing that's coming to my head. For the next one, we have the vertical angle thing again. These are vertical, so they're equal. So I can just say 10x minus 22 equals 8x plus 12. You're going to be using strategies like that throughout. Oh, you can't see that, sorry. I said these two are vertical. So this equals this. I can set that up, solve it for x. Pretty simple. After I get x, though, for this one, I'm going to need to plug in and actually find some arc measurements, which shouldn't be a problem. Just some simple substitution. For here, for this number 9, I have a diameter. That means this one plus this one, these two angles, and their corresponding arcs would add up to 180. So I could write 5x plus 23 plus 17x minus 41 equals 180. I can solve that for x and then plug in to get the arc measurements. So that's pretty much that. Central angles and their arc measures, not too big a deal. Send me a message through Remind or send an email if you need more help with this one.